Welcome, Wisdomers. Today we are diving into a critical concept in data science and engineering: outliers. To understand this, let's revisit our tip amount dataset. Imagine a scenario where a customer has a total bill of $100. Under normal circumstances, we expect a tip of approximately $10. However, due to exceptional circumstances, perhaps extreme customer satisfaction or drunk, a customer leaves a tip of $100. This specific data point is what we call an outlier. If we visualize this on a dimensional plane, you will notice that while most data points cluster together, this specific point is positioned significantly far from the rest. In engineering, identifying these data is the first step toward building robust, real-world systems. First, let us examine how outliers fundamentally impact the performance of our machine learning models. Consider our current dataset through the lens of a linear regression model. As we have previously discussed, the objective of linear regression is to determine the best fit line. This line is identified by minimizing the loss function, which is essentially the total distance between the actual data points and the model's predicted values. Now, observe the visual transition on the graph. Because of the presence of an outlier, the model attempts to minimize its overall loss by pulling the regression line toward that extreme data point, while the model is mathematically trying to be accurate. By reducing the loss, imagine the consequences if our dataset contained 2 or 3 such outliers. The best fit line would skew even further away from reality, leading to a complete failure in predictive accuracy. This demonstrates exactly why identifying and eliminating outliers is a critical step. Now let's explore the 2 primary levels of outlier detection: univariate and multivariate. Univariate analysis refers to the examination of individual columns in isolation. Taking our tip prediction dataset as an example, our first objective is to identify unusual values within each specific feature, such as the total bill, number of guests, or service rating, without considering how they relate to one another. To achieve this, we employ the interquartile range IQR technique. As you will remember from our Python data stack course, IQR is a powerful statistical tool that allows us to define clear mathematical boundaries. By calculating the spread between the 25th and 75th percentiles, we can objectively isolate the values that fall too far outside the norm, ensuring our individual columns are clean before we move to more complex analysis. After performing univariate analysis on each feature, let's review the results. In the total bill column, our IQR plot clearly highlights $1,200 as a significant outlier that must be removed. Moving to the guests feature, we apply the same logic and identify 50 as an extreme value. Consequently, this data point is also excluded. Next, we examine the service rating column. Here our analysis shows that all data points fall within the calculated mathematical boundaries, meaning this specific feature contains no outliers. Finally, we apply the IQR technique to the tip amount, where we observe an extreme value of $500. By identifying and removing these individual outliers across our columns, we ensure the quality of each feature before moving forward to multivariate analysis. Next, we transition to multivariate analysis, where we identify outliers by examining the relationship between multiple features simultaneously. For example, take a look at our dataset. Consider a row where the total bill is $150 and the tip amount is only $1. Individually, neither of these values is necessarily outlier. However, when we plot them together, This data point falls significantly outside the expected pattern, marking it as a multivariate outlier that must be eliminated. To detect these complex relationships across multiple dimensions, we utilize specialized techniques such as Mahalanobis distance, isolation forest, dB scan, and principal component analysis. Each of these methodologies provides a unique way to safeguard our models, and we will explore them in detail in our upcoming classes. Thank you for your time and dedication to learning with us today. If you found this content valuable, please consider sharing it with others and subscribing to our channel for more educational updates. To further reinforce your knowledge, we invite you to visit our learning portal at www.wisdomers.in, where you can access interactive quizzes and hands-on projects designed to take your skills to the next level.